Hello, my little mathematicians. Today we are going to explore Mod 11, Equations and Inequalities. As always, feel free to try it yourself. So pause the video, try it yourself, and then unpause it and come back and join us to check yourself. All right, so number one, if you tried it, I always like to put the variable on this side and then the number that it's talking about right here on the right side, -2. Okay, now for my inequality sign, the arrow is facing to the left, so that means that they're getting smaller, so a less than sign. So I'm going to put a less than sign. Or look at this arrowhead, kind of looks like the inequality sign right there, right? Now if this was shaded in, it would be a line underneath, but since it's not shaded in, it's not including that point. Okay, for the next one, x, and we're talking about 1. And the numbers are getting bigger. It's going to the right. So it should be a greater than sign. See, the arrowhead looks like a greater than sign. And it's including that point, so there's a line underneath of my inequality because it's greater than 1 and equal to 1. Okay, my next one, this time they want me to graph it. So I'm going to draw a circle at 3. I'm not going to shade it in because it's not including that point. And the arrowhead is going to the right, so they're getting bigger. And look, the great big open end is facing the variable, so numbers get bigger to the right. Okay, this one is at -1, so I'm going to draw a circle there. And this time I am going to shade it in because it's including that point of -1 because there's a line underneath saying and equal to. Okay, now the little tiny dot end is facing the variable, so that means they're getting smaller, right? It's the less than sign. Or look, this looks like the arrowhead right here, facing to the left. Okay, you could always use the arrowhead trick when you have the variable on the left. All right, now they want us to write the equation or expression or inequality from the word phrase. It says a number is less than or equal to 10. So some number, we don't know, is less than or equal to. So is kind of like a form of an equal sign, but then because it says less than or equal to, I know it's an inequality. So it's less than or equal to 10. Okay, the next one says the product of x and 5, so 5 and x. And when you say product, you know it's multiplying. Please don't use an x to represent multiplication because otherwise it would look like 5x times x, which is 5x squared, and that's not what this is saying, okay? So we don't want to use x to represent multiplication anymore. This is saying 5 times some number x is greater than, so greater than sign, 8. The next one, the quotient, so I'm dividing, of a number, so we don't know, and 5 is, so equals 20. See how I kind of write these as I read them? Okay, the difference means subtract. 9 comes first, and so after the minus sign, some number is less than. So a less than sign, no line underneath because it's not including that point, 45. Now, some of you guys are like, well, I remember before, we have like less than and it was just a minus sign. And then this time is less than, there's an inequality. Let's go through the difference of how they could look, okay? So if it just says 4 less a number, that's just a minus sign, okay? So 4 minus some number means equals 20. Now, when it says less than, that means it's being subtracted and it's moving it to the back, so behind that. So when you have your minus sign, it's moving the 4 to the end, like you're taking 4 away from what? Some number. And that answer is equal to 20. Now, less and less than is actually different too when it's a is less than, because is less than means that it's an inequality sign, okay? So 4 is less than a number plus 20. So see the slight differences in those? Again, if you see the word is less than. Is a form of an equal sign, and an equality is kind of like an equal sign. So this, if it says is less than or equal to, it's an inequality less than sign. But if it's just less than or less, it's a subtraction sign. Less than moves this number to the end. If it's just less, it's in the order that it comes, 4 minus x. But if it's less than, it switches these. If it's is less than, it's an inequality. Okay, I think we've killed it now. But you can see there's slight differences. So I wanted to make sure that we established those differences. All right. The next one says, write this as an algebraic equation or inequality. And it says the sum, so plus, of y and 2 is greater than or equal to, so the line underneath, 5. Again, it's easiest if you write it as you read it. Okay. This one, you're talking about, Autumn has $100 at most. So some amount that we don't know, and it's being compared to 100. Now you see at most, and you're like, oh, it's a greater than sign. But remember that I said whenever you see the word at or no with these inequalities, it's actually the opposite way you think. So instead of it being a greater than sign, it's a less than or equal to sign. Because if you think about it, go back to like something that you can rationalize. I always fall back to, okay, you can be at most 2 years old to get into Disneyland for free. So can you be older than 2? No, you're less than or equal to. If you're equal to 2, you get in for free. If you're 1 or 0, you're like 0. Yeah, if you're in your mom's tummy, you get in for free. If you're a few months old, you get in for free. But as soon as you're over 2, like think of you, can you get into Disneyland for free? No, you can't. Okay, so it's a less than sign. If it says you can be at most 2 years old to get in for free, it's a less than sign. Okay, and then you apply that to here. Or just remember the quick trick. Whenever you see the word at or no, it produces the inequality sign. That's the opposite way that you think. Okay, if you don't see at or no, it's just basically exactly like what it looks like or sounds like. You're talking about some temperature and 70 degrees, and it's warmer than 70. Is it equal to 70? No, it's just warmer than it. So it's greater than. Okay, and now we're going to practice solving some equations. Remember, I know that you know the answer to this. We made these baby problems, but what we're really quizzing you on is showing the inverse step. Okay, so that when they get harder next year and you can't just do it in your head, the steps are already second nature to you. So that's what we're quizzing you on, is the steps. I know that you already know the answer to this, okay, but we're quizzing you on the steps. So what are the steps? Get x by itself. How do you do that? Well, what's the inverse of plus 2? It's minus 2. Okay, now 2 minus 2 cancels because that's 0, right? 2 minus 2 is 0. So you have x plus 0 are just x. You isolated your variable. You got it by itself by doing the inverse step. But whatever you do to one side, you have to do to the other. Now 54 minus 2 is 52. Okay, so we want to see the inverse step, and we want to see it on both sides, because you can't just do whatever you want unless you do it to both sides and show that these cancel. That's how x got by itself, and then simplify this side. Now in the answer column at this point, that's when I would write your x equals 52. And if you're typing it in the computer and it says, please use numerical values only, or only numerical values are accepted, that means you can't type x equals 52. You would just type 52 because they just want the numbers of 52. We also want you to get in the habit of checking. How you check? You write the initial equation. You substitute in what you think the answer is for x. So I'm going to replace x with 52. Now simplify. 52 plus 2 is 54. Bring down that equals, bring down that 54, and you get 54 equals 54, a true statement. So you know with confidence that 52 is the right answer. Now, some people are like, what's the point of checking? Okay, what if you accidentally, let's say you thought the answer was 56, okay? You just went way too fast. You accidentally put 56. You glanced at it, and you're like, yeah, it makes sense. Okay, well, if you checked it, you would replace x with 56. You'd get to here and you go 56 plus 2 is 58. Bring down your equals, bring down your 54, and you're like, wait a minute, that doesn't make any sense. 58 doesn't equal 54. And so then you would erase this, and you'd erase the problem, and you'd try it again. That's the whole point of checking. If you end with an untrue statement, you know you did something wrong, and you retry the problem. If you end with a true statement, then you know that what you substituted in was the right answer, and that's what you would write in your answer column, 52. Okay, so again, I know that you know that the answer is 52, but I want you to practice checking so that later on when they get harder, you know how to check. It's second nature. And then you can hopefully catch some errors. And who knows, maybe some, even on this easy quiz, maybe you may have rushed, and when you check it, you'll catch those mistakes that when you turn it in, you for sure get 100%. Okay. But again, part of your points are going to come from showing the inverse step and checking yourself. Okay. Now for this one, again, to get y by itself, I want to do the inverse of -4, which is adding 4. I do that because 4 minus 4 is 0. And now you have y plus 0, or just y. Whatever you do to one side, you got to do to the other. 40 plus 4 is 44. Okay, I want you to get your full points on the quiz. Half the points are going to come from showing the inverse step and checking. The other half comes from the right answer. So yes, even though you got the right answer, you might only get a 50% on the question if you don't show your work properly. Okay, so check it. That's why I just put a check mark here rather than writing out the word check. I write the original equation. I replace the variable with what I think y is. And then I simplify. 44 minus 4 is 40 equals 40. That's a true statement. So then with confidence, you can write y equals 44 in the answer column and move on to the next question, knowing that you for sure got it right. Okay, if you haven't been pausing and trying them yourself first, why don't you go ahead and do that? Okay, now that you unpaused and you're back with us, let's check and see how you did. The inverse of subtracting 5 is to add 5. Whatever you do to one side, do to the other. Now those cancel because 5 minus 5 is 0. Bring down your e. And 26 plus 5, that's 11. Carry the 1. 1 and 2 make 3. I would write e equals 31 in the answer column. Then when I go to check it, here's my original. I'm going to replace e with what I think it is. And then check it. 31 minus 5. You have to borrow. 11 minus 5 is 6. Bring down the 2, and you get 26. Bring down the equals. Bring down the 26. True statement. So you're like, woohoo, I'm right. I can move on. For these ones, when you have a division problem, do me a favor and please rewrite it vertically or rewrite it as a fraction. So whatever comes first goes on top, and whatever comes second goes on the bottom of your fraction. Okay, I want you to rewrite it like this because then it'll be easier for you to show the inverse step. This is saying k divided by 4. The inverse of dividing is to multiply by 4. I do that because then these cross cancel. Because 4 divided by 4 is 1. This 4 divided by 4 is 1. You have 1 times k, which is just k. But whatever you do to one side, you have to do to the other. So I need to multiply it by 4 as well. 8 times 4 is 32. So I would write k equals 32 in the answer column. Before you move on, just double check. And replace the k with 32 divided by 4 equals 8. 32 divided by 4 is 8. Bring down your equals, bring down the 8. That's a true statement, so you know that you're right. Okay, my next one. Draw a line down from your equal sign. These are being multiplied. The inverse of multiplying is to divide by 5. Whatever you do to one side, you have to do to the other. 5 divided by 5 is 1. So you have 1 times h, or just h. And then when you simplify this, 45 divided by 5 is 9. Okay, we always want to check. Here's my original. Replace your variable with what you think the answer is. And then simplify. 5 times 9 is 45. Bring down your equals. bring down your 45, and you have a true statement. So then with confidence, you can write h equals 9 in the answer column because you know that that's the right answer. Okay, this one is a division problem. The inverse of dividing is to multiply by 2. Whatever you do to one side, you do to the other. Those cross cancel and become 1, and 1 times y is just y. 14 times 12, if you need to work it out, please don't be ashamed, okay? You're less likely to make a mistake if you take the 2 seconds to work it out. 4 times 2 is 8. 2 times 1 is 2. So you get 28. Okay, write that in the answer column, and then you check it, okay? So y over 2 equals 14. Replace the y with 28. And then simplify to see if it makes a true statement. 28 divided by 2 is 14. Bring down the equals, bring down the 14. That's a true statement, so you know 28 was indeed right. Okay, my next one. Draw a line down. The inverse of multiplying by 3 is to divide by 3. Whatever you do to one side, do to the other. 3 divided by 3 is 1. So you have 1 times p, or just p. 12 divided by 3 is 4. Now I'm going to check, and you have 3p equals 12. Substitute in what you think p is. You think it's 4. And then simplify. 3 times 4 is 12. Bring down your equals. Bring down your 12. That's a true statement, so you know that p equals 4 is the right answer. Okay, and the last one of this type. You have 7 times r. The inverse of multiplying is to divide. And then 7 divided by 7 is 1. And 1 times r is just r. Variables isolated, so move on. When you divide it on the other side, 63 divided by 7 is 9. Write r equals 9 in your answer column on the test for a test. And then check it. Okay, original, substitute in what you think r is, and then simplify. 7 times 9 is 63. Bring down your equal sign, bring down your 63. That's a true statement. Woohoo, you know you're right. Okay, now for this one, it says choose all equations where y equals 5 is a solution. So essentially, this is saying, hey, I solved this, and I think the answer is 5. Am I right? Can you check it for me? So you don't have to actually solve this. You're just doing the checking part. Again, you don't have to solve. You're just doing the checking part for these people. And I'm saying it that way because some of these equations, we even wrote them in a way that you don't necessarily know how to solve them yet. Like if it has a variable in the bottom, you don't know how to solve it. If it has a variable that's negative, you don't know how to solve it yet, but you will next year. So what you do know how to do is you know how to check. So just substitute in 5 for all the y's and see which ones make a true statement. If it makes a true statement, then you know 5 was the solution to that equation. So I'm going to replace the y with a 5. 5 minus 2 equals 3. And then simplify. 5 minus 2 is 3. Bring down your equals. Bring down your 3. That's a true statement. So that one works. Okay, the next one says 1 over y, or 1 over 5, equals 5. I mean, just look at that. If you didn't write that down, you might have been fooled and been like, yeah, 5 divided by 1 is 5, so it's true. But if you wrote it, you'd see 1/5 is totally not the same thing as 5. That can't simplify anymore. It's just 1/5. So that does not work. Okay, this one says 5 divided by 30 equals 6. Again, if you just did this in your head, you might think 30 divided by 5 is 6. Yeah, that's right. Okay, but if you see it this way, 5 divided by 30, go ahead and reduce that by 5. And 5 divided by 5 is 1, and 30 divided by 5 is 6. So you get 1/6 equals 6. Is that true? Totally not true. 1/6 is not the same thing as 6. 5 divided by 30 is 1/6. If it was 30 divided by 5, sure, yeah, it would be 6 equals 6, and it would work, but that's not what it's saying. Okay, 2 minus 7 equals 5. Look carefully at this. This isn't saying 7 minus 2, it's 2 minus 7. This is actually a negative 5 equals 5. Totally not true. And then this one, you have 35 divided by 5 equals 7. Well, 35 divided by 5 is 7. Bring down your equals, bring down your 7. That is a true statement. So A and E were the only ones that actually worked. Okay, for my next one, I want to choose all solutions for the provided graph. So if I look at the graph, negative 4 is over here. Is that the direction of the arrow? No. Negative 2 is right here where the dot is. So do I include it? What do you think? Well, if it was shaded in, yes, it would include the point negative 2. But because it's left open, it's only the values greater than negative 2, not including it. So again, because it's open, it's not including negative 2. But if it was shaded in, it would have included negative 2. And then 0, yep, it's greater and it's in the way of the arrow. 3 is greater right here, so that's a solution. 5 would be right here, that's a solution. And 100, even though it's not on the graph, it's still in this direction and the arrow keeps going. So yeah, 100 would fit as a solution because it too is a value that is greater than negative 2, right? Okay, hopefully you got all of those right. Let's move on to the last page. It says simplify the expression. What does that remind you of? That's right, PEMDAS. It doesn't go away, does it? If in case you forgot, parentheses, then exponents, then multiplication or division, and then addition or subtraction. Multiplication and division always comes before addition and subtraction. But when you're deciding between multiplication or division, you do whatever comes first. Again, multiplication does not always come before division. You do whatever comes first from left to right. But these two always come before adding and subtracting. And then when deciding between adding and subtracting, adding doesn't always come before subtracting. It's whatever comes first among those two, go left to right. Okay, let's try it. And again, you can always pause it and try it yourself first. Okay, and now if you unpaused it and you're back with us, I don't see any parentheses, but I do see exponents. What's 3 squared? Hopefully you put a 9, because 9 is what 3 squared is. It's 3 times 3. It's not 3 times 2. It's 3 times itself 2 times. Okay. Parentheses are gone. Exponents are gone. Multiplication or division, right here. Again, when deciding between multiplication and division, you go from left to right of whatever comes first. 30 divided by 5 is 6. Bring down everything else. Okay, there's still some multiplication or division left. That's 12 minus 7 minus 9. Okay, and then 12 plus 7 is 19 minus 9, and 19 minus 9 is 10. Okay, for my next one, parentheses are right here. 5 times 2 is 10. Bring everything else down. Parentheses are down to a single number. Exponents come next, and 3 squared, we already established, is 9. Okay, then we have multiplication or division, and you go from left to right. 30 divided by 10 is 3. And then 3 plus 7 is 10, and 10 minus 10 is 0. Perfect. Now, do you notice something? Right here, why did this randomly all of a sudden turn into a 10? I don't know, but I've seen this happen on kids' tests. So before you just move on, double check. Okay, you bring this down, this down, this down, here, and here. Okay, and then you're to this step. And then you simplified this, bring this down, go slowly and don't rush. Okay, because then as people are rushing, they accidentally see this 10, like I don't know what goes on in their head. Okay, so again, bring your steps down slowly. And then right here, I accidentally put a 9 there, right? And sorry, I put a 10 instead of a 9. Then double check, okay, that simplified to 3. We brought the 7, we brought the 9. Then I go here, that's 10, and I bring down the 9. And 10 minus 9 is 1. Okay, now I wanted to do one of those on purpose because I see kids make so many mistakes where they just rush through it, and then they aren't careful about what they bring down each time. And then it doesn't even make sense in my mind of what they bring down and why. So please, please, please go slowly when you're bringing each step down and kind of almost double check that you didn't miss anything, okay? Because I'd hate for you to do all this work and then miss it because you weren't careful about what you brought down. All right, for our next one, inside of your brackets, okay, because that's like a form of parentheses, okay, I want to focus away on that. And then within the brackets, order of operations still apply. So I look for parentheses first. There they are. And within the parentheses, order of operations still apply. So before you subtract, you need to divide. 10 divided by 5 is 2. Now, as we just established, because I realized that I was going really fast, and I'm like, oh, I don't want them to do that. So I'm going to slow down a little bit, okay, and then make sure that 20, those combined to make the 2 minus 10, and then that. Okay, now move on. And that's why I do this little caret thing, because that shows that these two combine to this, and I don't accidentally bring that 10 down or accidentally bring that 5 down again, because I've seen people do the same operation twice because they don't look that, hey, those two numbers combine together to make that 2. All right. Again, I'm sorry for like showing random mistakes that can happen, but I really don't want you to make those same mistakes on your quiz. All right, right here inside the brackets, within those, I look for parentheses, and 20 minus 2 is 18. Bring down the minus 10, close in those brackets, and we're here. Okay, now I have that 18 minus 10, which is 8. Okay, I had to get all of this to one single number because that whole thing is being squared. And 8 squared is 64. Because it's 8 times 8. Not 8 times 2, but 8 times itself 2 times. Okay, my next one. Okay, again, it looks super confusing. So just kind of like put your fingers to close out the rest of the world and just focus on the inside of those parentheses. Within the parentheses, before you subtract, exponents come first, right? So that's 2 times 3 or 2 times 2 times 2. Hopefully you said 2 times 2 times 2. It's 2 times itself 3 times. Well, that 2 times 2 is 4. Bring down that 2, and 4 times 2 is 8, right? 2 times 2 is 4. 4 times 2 is 8. So 2 cubed, or 2 times itself, 3 times is 8, okay? Again, go slow. 2 cubed, bring down the 8, minus 20, and that whole thing's being squared, minus 1. Okay, just focus on here, inside the parentheses. 20 minus 8 is what? It's 12. Okay, the parentheses are down to a single number, check. Now I move on to exponents, which is 12 squared. So 12 times 2, right? Wrong. Okay, it's 12 times itself 2 times. 12 times 12 is 144. Bring down the minus 1, and 144 minus 1 is 143. Okay, if you're getting all these right, congratulations. These are hard. The next one says, Mrs. Rowland was having a party in her kindergarten classroom. She had 54 cookies to give to her students. She had 9 students and gave each of them the same number of cookies. Write an equation using C to represent the number of cookies each student received. So I have a total of 54 cookies. She had 9 students, so I'm dividing up amongst 9 students, and then that's going to determine how many cookies each kid gets. Okay, or you could have said 54 divided by C equals 9. This is saying the same exact thing, But I don't really like it this way when you have the variable in the denominator. Okay, I would avoid writing it that way, and I'll show you why down below. Okay, and then the inverse of dividing is to multiply. So you could have done 9 times c equals 54 as well. Okay, so any of those ways would have worked. So let's focus on this one. When you solved it, your variable's already isolated, so you could just jump straight in. 54 divided by 9 is 6. So you get each kid equals 6 cookies. I like that one. This one's also a good one. 9c equals 54. Okay, how do you isolate your variable? Divide by 9, because 9 divided by 9 is 1. And 1 times c is just c. And 54 divided by 9 is 6. So you still get 6 cookies. Now, here's why I don't like this one that I crossed off. I mean, technically, if you're picking from multiple choice, yes, this equation would work. But I don't like it because you're not going to divide by c to get it, because c has to be on top. This is saying 1 over c, which is bad. So I'd have to bring the variable up, and then those cancel, and I just get 54, and then I'd multiply this side by c. And then now that it's up, because we don't want 1 over c, we want just c. So I had to bring it up to the top. And then when I did that, I'd do the same thing to the other side. And now this looks like almost what I started with over here. So I would divide by 9 to get it to cancel, because 9 divided by 9 is 1, and 1 times c is c. And then you divide this side by 9. 54 divided by 9 is 6. Now, if some of you are like, what just happened? I have no idea. Again, because this is hard. This is for much later, like next year. Okay, and this is why I said you don't know how to solve it when your variables in the denominator, because you don't. This was so confusing, right? We know how to solve these. This is why we want to write it like this. Don't write your equation with the variable in the bottom, because it's weird when you try to solve for the variable and it's hard, right? So don't set them up like that. Okay, now you could check it. Like if they said, hey, here's an equation. Is 6 the right answer? Well, you can substitute in a 6 and be like, okay, 54 divided by 6 is 9. Bring down the equals, bring down the 9. 9 equals 9. Yep, 6 would work. So you can check an equation with the variable in the bottom, but you don't know how to like solve it and do the inverse step. Okay, I hope I've killed it as to why we shouldn't set up an equation with c in the denominator, because it's just too hard to solve when we solve it ourselves. Okay, last one. Brooklyn had 2 gift cards to Target. One was worth $30 and the other had 5. Okay, so we have 2 gift cards, 30 and 5. She used some of her gift card money at the store to buy some makeup. She then had a total of 12 left on her gift cards. Okay, so she used some amount. They specified use D to represent how much she spent. So some D amount is what she spent. And now she has $12 left. So that equation is good. It would work. Okay, or you could have combined these and said she had a total of $35 in gift cards. She spent some amount, and now she has 12 left. These equations work, yes. However, you don't know how to solve it when D is negative, because let me just show you. You want D equals something, not negative D. So I would have to add D to get it to cancel. D minus D is 0. And then you'd have to add it to this side. And then you get 35 equals 12 plus D. And then you would solve for D. Minus 12, minus 12. And you get 23 on this side. Those cancel, and D. That was a like extra added step, right? So I don't like to have it where the variable is negative when I have to solve for it myself. So instead, I'd be like, okay, fine. Then let's do it where we have a positive D. So whatever she spent plus however much she has left equals the total amount of money that she had to start with on her gift cards. Okay, or you could have simplified that to D plus 12 equals 35. Okay. Either one of actually technically all four of those equations work. But I like these two best because when you have a negative d, again, they're kind of too hard to solve. Versus this one, if you just started with d plus 12 equals 30 plus 5, you would simplify the right. 30 plus 5 is 35. And then you're right to this equation. And to get d by itself, I would get rid of the positive 12 by subtracting 12, because now those cancel. 12 minus 12 is 0. And d plus 0 is just d. Whatever you do to one side, you do to the other. 5 minus 2 is 3. 3 minus 1 is 2. Okay, this is much easier to solve. Whether you started with this equation or this equation, you isolate your variable by doing the inverse of plus 12. And there you go. You get that she spent $23 at the store. All four of these equations are acceptable, but I prefer those. All three of these equations are acceptable, but I prefer this one or this one. Okay, but I still wouldn't mark you off if you chose this one or this one. It would just be really hard for you to solve showing inverse steps. Okay, hopefully you guys got almost all of these right. If not, practice similar problems in your notes and homework that we've covered, or extra practice pages that are similar to the ones that you missed. And congratulations, you've now mastered equations, expressions, and inequalities. You're going to do great.